What's up, everybody? It's Dan from SageMathTutoring.com, and here we have a video where we cover some problems that require using a compass and a straight edge. And these are sort of interesting problems to tackle, pretty unique problems. So I say we just dive right in. We only have 3 problems in this particular video. So based off of this one, construct PQ is parallel to RS using alternate exterior angles. So first of all, this is kind of a little bit messy, so what I'm going to do is redraw it. Okay, so I have 2 compasses here. You would only need 1 in real life, but I'm kind of using those 2 compasses for illustrative purposes. I might have to kind of flip it around, so rather than flip it around live, I'd rather just do that sort of, by just dragging it over. So let's sort of redraw this situation. Kind of looks like that, right? And we have P, which we'll say is right there. We have S, and we certainly have an R somewhere around there. And we want to create a line of PQ that's parallel to this RS. So ultimately, we're trying to make a line that kind of looks like this right here. Okay, kind of looks like that. Now the problem is that that's going to be difficult. Okay, the problem is there's going to be multiple steps involved with drawing that line, and specifically they're saying they want us to use a compass and use alternate exterior angles. Well, if you were, I'll draw like a phantom line here. Okay, I'll just draw this kind of phantom line. If you were to use alternate exterior angles, well, it would be a matter of using this angle and this angle. So really the task is to sort of get clear on this angle here, and then we're going to replicate the angle up here, and that's sort of the goal, and then we're going to construct this line. Now I am going to get rid of the phantom line because I actually think it's kind of distracting. I'm also going to go ahead and extend this a little bit because I can foresee that that could be helpful. Now, the general theme that I want my student who's watching this to remember is worry about the angle first, replicate the angle, and then worry about sort of this distance next, okay? Now, what I mean by that is we'll go ahead and take our compass, okay? We'll take our compass, and what we're going to do is we're going to put it here, and then we're going to go ahead and draw this sort of arc that goes like that. All right. Now, you're going to maintain the size of the compass. All right. Now, this next part's really important. So we're going to maintain the size of the compass. I'll just kind of switch to this one. Imagine it's the same compass, though. You're going to maintain the size of the compass, and then you're going to put the sharp point on, you're going to mark a point, first of all. You're going to mark a point, and then you're going to put the sharp point there. And then this is the important part. You have to draw an arc that goes like all the way. Move this out of the way just for now. You have to draw an arc that goes all the way like that. All right, that's important. Then what you do is you take the compass and you just measure that distance there. Okay, you measure the distance between these points here. All right, so that's important. And then you put the sharp point on that spot there, and you draw a new arc that cuts through. All right, where the sharp point is now here, and you're drawing this blue arc. Now, this might not be drawn to scale because, kind of these arcs are not perfect, but that's going to give you a new point that I'm going to make kind of big because it's not drawn to scale. But if you were to connect those 2 points, then it should be the case that it's going to be parallel lines. All right, it's going to be parallel lines through those. So hopefully that makes sense. So once again, put the sharp part here, draw the arc, plot a point, let's call it P, draw an arc that goes all the way through, and then use the compass to measure this distance, calibrate the compass so it's measuring that distance, and then put the sharp part here, and then draw your blue arc. That blue arc intersects the previous red arc, and that gives you a new point. All right, and then you have your parallel lines. Looking for constructing a trapezoid with ZO and ID as non-parallel sides. So this side and this side are going to be the non-parallel sides. So in other words, it's going to be some trapezoid that looks like this, where the top and bottom are parallel. But we could say that that's ZO, and we could call this ID. All right, so that's kind of our goal. But then they say that AB is the distance between the parallel sides. So AB is this altitude, which happens to be, of course, 90 degrees here, 90 degrees there. Now, for this one, what I would strongly recommend is step one is going to be a matter of drawing a long baseline, okay? A long baseline. So here that is, okay? Now, step two is going to be drawing a long line that cuts through, but in such a way that's perpendicular, okay? A long line that cuts through, but is perpendicular to the original baseline, okay? Now, you may start to notice that, in a way, the long baseline is going to represent this bottom, and we're about to draw a long line that cuts through the baseline in such a way that forms 90 degrees here, and we're going to overlay this AB on top of that. Okay, so how do you do that? Well, you could always just plot a point here, okay, and then you would be using your compass to, I'll kind of make this a little bigger. You'd be using your compass to draw this arc here, okay, like that. And then at that point, you would be, and you're really going to want to extend it, by the way, like that, right? And then you could draw another point here, okay? And you're going to keep the compass calibrated at the same size. Now I'm just going to use this guy, but I'm going to blow it up, all right? But imagine once again that it's the same compass, it's just that I'm flipping it around. All right, now remember, it's the same size as what you just did. You did not change a thing about the size. You're going to put it here, and then you're going to draw this arc, right? You're going to draw this arc right there. So I can move the compass out of the way, and that would look something along these lines. All right, once again, not drawn to scale. At that point, you would line your straight edge up with these, and then you would draw your straight line through there. Now, my diagram is going to be kind of messy, but hopefully you get the gist. It would go through, and that thing is going to end up being perfectly 90 degrees. Now, I'll just draw it like that. Once again, it's not drawn to scale, but my student who's watching, I'm certain she understands, because we've done this before. So that's that. I'll get rid of this, get rid of this. Now, it will be the case that this is 90 degrees, okay? At that point, you can then take note of this AB thing, and then use your compass to go ahead and calibrate perfectly to the size of AB. Now, I'd say that looks halfway decent right there, okay? Calibrating perfectly to the size of AB. And then what you would do is you would go ahead and put it here, right? You would put it there. And in that, you'd be able to mark off this point, okay? Now, perhaps I should have flipped it. All right, maybe if I flip it like this, you can kind of see what I'm talking about. So if it was like that, right? And then you could draw like an arc here. Okay, so hopefully that makes sense. So then we have our AB. Now that AB represents the altitude of the trapezoid, which happens to be the distance between the parallel lines. So now there's a question about how to draw parallel lines just in general. So it would be nice to have some other long parallel line across the top. And then we could kind of take it from there, right? Because we're going to need this parallel line that's across the top. So we're going to need this long thing. Now, one way of going about it is you could go ahead and sort of take advantage of the fact that you have this sort of triangle that you've created, right? You've had this triangle that you've created. Now what you could do is, if you could just create another replicated triangle over here, well then the line that would connect the tops of the triangles, that would be parallel with the bottom baseline. So in other words, we're going to replicate this triangle, okay? And then you're going to have it over here, and then the line that connects the two the tops of both triangles would be parallel. So how do you replicate the triangle? Well, you would start by replicating the distance between these 2 points here. So how could you do that? Well, you would just essentially use your compass to calibrate that distance perfectly, right? Calibrating that distance here. And then you would draw a new point right there. Okay, so that's that. And then at that point, you could then calibrate the distance between here, and we could do so using our compass. So we calibrate the distance. You could put it, and you could calibrate the distance there, and then we would just go ahead and move this so it's here. And then what we're going to do is we're going to draw an arc right there. Okay, and I'm going to do that, move this out of the way. This would end up being something that looks like that, right? Now, you have this perfect distance, right? And then what you could do is you could then, flip this around like that, keep that distance, and then you're going to draw another arc like that, okay? And the compass hasn't changed the calibration at all, and you're going to end up with this sort of thing like that, okay? Now at that point of intersection is going to be the top of that triangle. So in a sense, we have a triangle here, we have a triangle here. Now at that point, you can go ahead and connect the dots, and that would result in parallel lines, okay? Now, like I said in the last slide, there's going to be some inaccuracy due to the fact that I'm not using real compasses and stuff, but we're just going to go with it. So drawing a parallel line that goes across would look something like this, right? Something like that. And I'll just try to make it look perfect by moving it over. Okay, so there we go. So it's something like that, right? Now, in my opinion, the next part is sort of the easy part, to be honest, because then they say we just want this side ZO, which is right here, to be one of the non-parallel sides, and this side ID to be one of the non-parallel sides as well. Now that part's actually pretty easy in my opinion. You would just take your compass, all right? You would take your compass and you would go ahead and gauge this distance between Z and O. You would preserve that distance. You would simply find some point that you're going to call Z. Let's call this point Z right here. And then you would just draw this arc here. Okay, you would draw this arc like that. All right. Now what that would result in is this sort of, you would swoop it up like that. That would result in something like that. And that point of intersection would itself be the distance, the proper distance between Z and O, right? It would be the proper distance between Z and O. So that would be your O, actually. All right. At that point, of course, you can draw a line between them. right? Draw a line between them. So there that is. At this point, you would literally just do the same thing with ID. Um, we will go ahead and use this compass here. We're going to gauge that proper distance between I and D. At that point, we would literally just pick any old point to call D, because we're putting D on the bottom. Let's just call this D. Who cares? All right, we'll call that D. So that's D right there. Then you would take your compass that's at that proper distance, and then you would swoop it up like this. Okay, now only by coincidence does it look like it's hitting that, but it would be a matter of swooping it up like that, and then it would cut through here. At that point, you could then connect these, and we could call that, that point right here, I. Okay, so the colors are all kind of crazy, but that is how you do it. So once again, so this is a trapezoid. So once again, draw the baseline, get a long perpendicular line. This is the altitude, overlay the altitude on that long perpendicular line. Then use the triangle trick to get that top parallel line. Okay, use that triangle trick to get that top parallel line. And then you could just use the compass to gauge this length here. Pick a point to call Z. Do a little swoopy swoop there. That's going to be your O. Calibrate the compass to get the length of ID. Pick a point to call D. Doesn't matter where. Just call it D. Draw a point and call it D. And then once you have your compass calibrated to this length, you swoop over here, and then you call that point of intersection I. Connect the dots, and you have that side. Connect the dots, and you have that side. So that's your trapezoid. All right, constructing a parallelogram called gram with two consecutive sides, Y and Z, and angle A as one of the acute angles. Remember to mark and label your construction. So with this one, you could start by drawing a very long baseline. Okay, similar to the trapezoid, we can just get a very long baseline. All right, so here it is. At that point, what you can do is you can pick a point to call sort of A here, right? Any point on the baseline will do. I'm going to do it right here. And you just essentially take your compass and you would line it up similar to what they're doing here, and just line it up so that you have this distance here, and then you would put that compass here, and I would strongly suggest drawing sort of a big arc, okay, a big arc around like that. So in other words, it would look sort of like this, like that, okay, big arc around. And then what you do is you take the compass, I'm going to use this one, and you measure this distance here between these points. Okay, you calibrate that distance right there. Okay, and as a result of that, you take the compass, and then what you're going to do is put the sharp point of the compass here, okay, right here, and you're going to draw an arc like this. And what that would sort of look like is something along these lines. Now you have formed a point of intersection clearly. At that point, you can use your straight edge and connect those dots with a straight edge. Okay, so let me get the compasses out of the way. Get these out of the way, and we'll draw a nice line. Now I'm going to suggest make it real long. Don't mess around with that. Okay. All right. Now we've done that. Then one of the consecutive sides is going to be Y, so we'll put Y here. We'll put Z across the top. we're going to put y here. Now I see no reason why we can't just kind of do that right away. Okay, so I think my student who's watching this could probably get this part pretty quickly, for sure, where you would just use one of the compasses, right? And you would gauge that distance. And then after that, of course, you would be bringing the compass with that distance here, and you would put the sharp point on A, and then, draw an arc right there, which I'm going to do. Okay, so let's say that ended up being right around here. That gives us our new point of intersection. And I think my student, of course, understands that that right here is y. Okay, right here. So that's kind of good to know, right? Okay. So at this point, we need to draw a parallel line that goes across the top. I'm going to suggest a similar method that we used in the earlier, like the first problem that we did. Now, what we could do is we could take advantage of the fact that we already have this arc here, and we're going to draw a similar arc that goes up like that. Okay, we're going to draw a similar arc that goes up like that. And the way that you could do that is you could sort of measure, let's say, this distance here, right? Measure the distance between here and there, and then take your compass, put it there, and then what we're going to do is we're going to draw an arc that cuts through this line up top here. Now, the sharp part is at the end point of segment Y here, right? And we're going to draw an arc that goes like that, and I'll just show you what that would look like. That would look something like, this, right? That. Okay. Now here's the moment where you may recall we're now going to gauge the distance between this part of the angle and this part of the angle. We're going to gauge that distance, and then we're going to take things from there. Now how do you gauge that distance? Well, of course, you would use the old compass, right? So you would gauge that distance perfectly. You would maintain that, and then you would put the sharp part here where the arc had crossed the this longer sort of line here. You would put the sharp part there, and now we're going to do a little arc here. All right, we're going to do a little arc here. So what would that look like? Well, that would look something along these lines. All right, remember the sharp part was here, and we drew the arc there. Now that gives us a new point to work with right there. Now, it is between those points that we will be able to draw our parallel line. Okay, it's a parallelogram, so we definitely need that parallel line. So I'm going to draw it nice and long though. Okay, so there we go. Now, believe it or not, my student watching this probably like, oh my God, how am I going to remember all this? Well, I think you should practice it. For example, I think you have lunch tomorrow for my student watching. Practice it, if you can. So, the next part's easy though. I mean, we already have Y, but now we just need Z. So, the bottom line is we have the parallel lines, so we're going to be fine. So we could just literally measure Z, right? Measure Z by turning this and kind of gauging that, right? And then we could transfer it here. It is kind of short, right? Put a little mark there. Now, we're going to need that very same distance on the bottom, so I say we go ahead and just transfer it and put a little point here. Now, it is the case that we need to Well, I need to move this compass out of the way. So let me just do that real quick. So move the compass out of the way, which is awesome. So I'm going to then just remind everyone that this distance right here is what we call z. Okay, that's this distance right here. So we've successfully done that. So in other words, you can put z on top and you can put z on the bottom, and then all you need is a straight edge to connect these points, and then you have a parallelogram, and it's really just as simple as that. So in a way, it's almost like the hard part, you could say, is just replicating, draw the baseline, replicating that angle here, and then remembering how to get a parallel line by using the same angle. Okay, using the same angle. So to recap though, let me just summarize what we did. We drew a long line that can be done just with a straight edge. At that point, we created this angle. We replicated this angle here, and we did so by gauging this distance, choosing a point to call A, drawing this arc right here. Okay? Then we gauged this distance. We put the sharp part of the compass here, and then we sort of drew another arc, that green one right there. And then we had our point of intersection between the green arc and the previous blue one. And that point of intersection, we used a straight edge to connect A with that point of intersection. And that's how we got the angle. That's how we replicated the angle. Okay. At that point, you can replicate the length of Y. Just place it on this segment. Mark off where it is right there. Okay. And then we had to draw this parallel line here, which is not easy. We have to draw that parallel line, and that's where you would have to replicate this angle up here. So how do we do that? Well, we gauge this distance with our compass. We put the sharp part of the compass here. We then drew this arc. We made sure the arc cuts through this part here, right? Then we gauge the distance between this part of the angle and this spot on the angle with our compass. We gauge this distance. We put the sharp part of the compass here, and we drew this green arc here. Now the place where the green arc intercepts the blue arc, that's our new point. And with that point, we connected these points with a parallel line. Now really the rest is easy. Replicate the length of z, slap it on this parallel line, there it is. Recognize that this length of z is going to be the same as down here, so you put it down here, mark off that point, and then you just draw a straight line between these 2 points, and you have your parallelogram. Okay, pretty crazy stuff. This is the first time I've ever made a video on this stuff, and it might have been a little clunky, but for my student watching, hopefully it was helpful, and for the rest of you, if you have any questions, please let me know, and I will talk to you later. Bye.